7 in my GCSE revision series. This episode will be looking at equations of tangents and tangents to circles. That again is a higher tier topic, so if you're doing higher tier GCSE in the summer, this will help you. I'll be going through a bunch of past paper questions and all sorts of questions regarding tangents to circles. So if you're interested in that, stay tuned. If you are looking at this on YouTube, I'd really appreciate a like or a subscribe. Also, you can leave comments in the comments section below. If you're watching this on Twitch, you can also leave suggestions for future topics in the chat box next to where you see this on Twitch. Otherwise, it will be just on the comment section below in YouTube. Okay, so here we are looking at question number 1. And it's a circle question, very basic circle question. Would normally be these questions towards the end of the higher tier exam because they require a little bit of working around, and they're always worth multiple marks, so quite a lot of information in there. Principles remain the same pretty much for every question. Basic principles are work out the gradient of the line that goes from the centre of the circle to the radius, so work out that gradient. Work out the gradient of the line that's perpendicular to that, and then work out the equation of the tangent. Okay, any question will probably always do that. I would always sketch the tangent in, the radius in, just to show where it is, and of course the line that's perpendicular to that would be the tangent. So you're thinking through those things all the time. We're given a point here, 4, 3, which is just on the diagram as well, and it's asking us to find the equation of the tangent. So let's just go through those steps to show you. This is a very basic question, just to show you. So first of all, let's work out the gradient of the radius from O to P. So how do we do that? So gradient is change in y over change in x. So change in y over change in x. So if I sketch those little bits in, you can see this here is 3, because that's the coordinate. This here is 4, again coordinate, you can see that. So it's 3 over 4. The gradient of the radius here, OP, is so gradient of OP is 3 over 4, 3/4. So you should have learned that the gradient of the line that's perpendicular to that would always be, this times the gradient of this is always -1, so you do -1 over this. The way to think about it is just to flip this upside down and put a minus in front of it. So the gradient of tangent here will be -4/3. So you flip this upside down and put a minus in front of it. So 3/4 obviously becomes 4/3, -4/3. So then you're working out the equation of tangent. So y equals -4/3 x plus c. So y equals mx plus c is a general form of a straight line. You know that, y equals mx plus c. This is the gradient, -4/3. We don't know what c is yet. We have to work it out. How do we work it out? We've got a point here, 4, 3. So we put y is 4 and x is 3 into this equation. That should hopefully help enable us to work out what these values, what the c value is. So we're going to put those values into there. So what have I done there? I put y is 3 from up here and x is 4 from up there. So we're going to work out now what c is. You have to be pretty good at fractions to be able to do these, because often these questions come up in a non-calculator exam, so you'd need to work these things through with fractions. Top paper fractions is traditional, so you'd normally work with top paper fractions. Here you would be trying to add the 16 over 3 to get it over the other side, so 3 plus 16 over 3. Again, if you're good at top paper fractions, you'll know that 16 over 3, and this added up will be the same as this, because you've got to do a lowest common denominator. That's 9 plus 16 over 3 equals c, so that's 25 over 3, and so that's going to be the equation then of the tangent will be this bit up here. So this bit up here, y equals -4/3 x, and then plus this 25 over 3. So very basic question, very basic answer. Sometimes you get asked for the answer in a form something y equals something x plus something. You can multiply by 3 here to get it into a slightly different form. Depends on the question. Either is acceptable in this instance, but it just depends on the question and what they're asking you to do. So general principles again. So number 1, always work out the gradient of the radius. Number 2, work out the gradient of the tangent. Number 3, work out the equation of tangent. You'll need to do that on every single question, regardless of what the question asks you. Those are the 3 things you're always going to need to do. So this here is a slightly harder question, but a very similar sort of scenario. So it's asking you for the line L. There's no diagram for this question. It's unusual. Usually you get diagrams. So we're going to draw a diagram in a second. So the line L is a tangent to circle x squared plus y squared equals 40 at the point A, and A is the point 26. The line L crosses the x-axis at the point P. Work out the area of triangle OAP. So there's quite a lot of information in that question. I'm going to sketch a little circle here and show you roughly 26. Show you what this is roughly looking like. So this gives you an indication of what it looks like. So it's just relevant to the previous question, really. Again, 3 principles. First principle is work out the gradient of the line OA. So we're going to do that. So work out the gradient OA. So the gradient OA equals change in y over change in x. So 6 over 2, 3. Work out the gradient tangent. That was the second principle. So gradient tangent is going to be minus 1 over this. So again, flip it upside down, put a minus in front of it. Think of this as 3 over 1, so it's minus 1 over 3. Work out the equation of the tangent. So y equals minus a third x plus c is the general equation of a straight line. We're going to put in the point 26 to work out what c is. So I'm going to do that now here. So that's what I'm doing here. And then you're going to have 6 plus 2/3. And again, you need to be quite good at fractions. So it's 20 over 3 when you do that. So the equation of tangent will be y equals minus a third x plus 20 over 3. Okay, so that's the equation of tangent here. Now it's asking out for the area of a triangle OAP. So on my diagram here, OAP, P will be the point here where it crosses the x-axis, and they're asking you to work out this triangle here. So we need to know what the point P is. In other words, where it crosses the x-axis. So where a line crosses the x-axis, where this line crosses the x-axis will be where y is 0. So if you let y equals 0 into this formula, we'll have this. Okay, so 0 equals minus a third x plus 20 over 3, so just put a 0 in for the y, 3, sorry. And then work out what x is, so multiply everything by 3 as well, so I think x is 20. So the point P was 20, 0. So if you're thinking of this as a triangle here, there's A, there's P, this is 20. This here was 6 because we know the change in, we know that coordinate was 6 earlier. So this is 6. So half the base times the height is the area of a triangle. So 20 times 6 is 120. Half of that, 60. So it's 60 units squared is the area of the triangle OAP. This question down here, question 5 with the circles and the equations. X squared plus y squared equals 4. You've got a point here. Again, no diagram for you really, but asking you to find the equation of tangent L at the point P. So again, you can draw a little sketch if you want. You don't have to, but you can. It sometimes helps if you do. So let's just imagine that that's the point P here. So again, first principle, work out the gradient of the line OP. So gradient OP, change in y over change in x, so this over that, so horrible this time because we've got horrible numbers, so right 7, root 7 over 2 over 3 over 2, so change in y over change in x. Again, dividing fractions is the same as multiplying by the same fraction upside down, so you'll get root 7 over 3 as your gradient. The gradient of tangent will be that flipped upside down with a minus in front of it, in other words, minus 3 over root 7. Okay, and then the third step was work out the equation of tangent. So you're going to have y equals minus 3 over root 7 plus x plus c. So minus 3 over root 7 is x plus c. We need to find out what c is. How do we find out the c? We put the x and y coordinates from up here. Y is root 7 over 2, x is 3 over 2. Okay, it's harder maths, but it's the same principles you're using. So you're going to go through root 7 over 2 equals minus 3 over root 7 times 3 over 2, because the x coordinate was 3 over 2, and then plus c, we're trying to work out what plus c is. So again, just using a little bit of maths to get this out. Okay, so minus 3 times 3 is minus 9, that's where that comes from, 2 times root 7. We're going to add root 7 over 2 and add this over. So root 7 over 2 plus 9 over 2 root 7 equals c. And again, need a common denominator. Common denominator would be 2 root 7, so I need to multiply everything by root 7 here. So I have 7 plus 9 over 2 root 7. That's 16 over 2 root 7, which is the same thing as 8 over root 7. So c is 8 over root 7, so the equation of the straight line will be y equals minus 3 over root 7x plus 8 over root 7. Okay, so minus 3 over root 7 came from there, and the 8 over root 7 came from there. Okay, again, you could multiply everything by root 7 to get it a bit nicer, but that'll do. That's the answer for now. Same principles as earlier, no different. This one here, again, same principle, just different questions really all the way through. So this one is saying this has got x coordinates p and minus 15. So it's slightly different because it's giving you not as much information as the previous question. So this is 15 from there to there. It's asking you for p, which is this value here. So it'd be really good to work out what this p value is first of all. You can see I've made a right angle triangle there, or you can put the values into this. I mean, it's effectively the same thing. So you could put, we know the point is on the circle, so we're trying to work out what the x coordinate is when you've got y as being 15. So you put x squared plus 15 squared, that's 225, so y squared, 15 squared, 225, equals 261. Take the two things away, so 261 take away 225, that's 36. So x is plus or minus 6. Now this is where the catch comes. You've just got to be careful to have your wits about you. We're looking for just the plus 6, because of course we can see it's on the positive side. So x is positive 6 here. So that's what p is. P is positive 6. So we know this point is positive 6 minus 15. Now we can fill that in. And then again, going back to the same principles from earlier. So number 1, work out the gradient of the radius. So that's changing y over changing x. So that's minus 15 over 6, changing y over changing x. So that's the gradient of the radius. And that will be, when you do it, minus 15 over 6. You have to work your way through that and understand what that is. And if you do that carefully, you'll be able to get that in its lowest terms. So minus 15 over 6 will be minus 2.5, so minus 5 over 2. And then the gradient of the tangent will be again, flip that upside down, put a minus in front of it, so it's 2/5. And then that means the equation of the tangent will be y equals 2/5 x plus c. We need to find out what c is, but we've got a point, 6 and minus 15. So we're going to put y is minus 15, and x is 2. X is 6 here, and then we're going to work out what these are. So again, just taking my time with this. 12, isn't it? 12 over 5. Just taking my time with it, really stepping my way through it carefully and understanding what it is. So again, you've got to be quite good with fractions. You have to recognise that 5 lots of 15 is 75, but you can do it. It's easy to do. So you become really good at these things the more you practice. So it's definitely worth your while practicing these things up. So you'll get minus 87 over 5 here for c. And so the equation of the straight line then will be y equals 2/5 x, and then minus 87 over 5. Again, it's relatively straightforward to do those. It's not too difficult at all, really. It's horrible numbers to work with, but the principles are the same thing all the way through. One more to do then, which is this one, which is a slightly unusual question, which is why I picked it out. So this one here is asking you for to prove algebraically that the straight line with equation x minus 2y equals 10 is a tangent to the circle with equation x squared plus y squared equals 20. So you can't do the principles we were just talking about. It's a slightly different problem. It's back to front. So the only thing you can do here is really look at the information you've been given. So this really is telling you that x is 2y plus 10. You can just rearrange that to get that. And of course we've got an equation here, x squared y squared 20. So I can put 2y plus 10 all squared plus y squared equals 20. Okay, because we know that x is 2y plus 10 from there. Now if you square these brackets out, again you've got 2y plus 10 times 2y plus 10. So again, using your quadratics, you can work out what that is. You will get this. And in gathering together all your like terms, you'll have 5y squared plus 40y. Sorry, I just need to squeeze that there. Plus 80. And then equals 0. And then you can divide everything by 5. So 8y plus 16 equals 0. And again, this is a very easy quadratic to factorise. It's just y plus 4 all squared, which basically gives you a repeated root answer. It's only one answer. Y is minus 4 is the only answer. And because it's only got one point where it hits, so the x corresponding point there will be, well, 2 lots of minus 4 is minus 8. And minus 8 plus 2 is, minus 8 plus 10 is 2, so x is 2. So the point is 2 comma minus 4. Because there's only one point where your line intersects with your circle, that proves it's a tangent. So that's what it's asking to prove. It's asking to prove it's a tangent. Because it's only hitting the circle once, that must be a tangent. So you're just going to put that note in here to make sure that they understand that you have to say it hits once. So that makes sure that you can prove that it's a tangent. Right, a couple more loose ends to tie up. There was a couple more questions I thought that I would show you, just on the same sort of topic, but connected to it. So these two final questions are both on what you call coordinate geometry, but they are similar in a lot of ways. So this one here, this is talking about two coordinates, minus 9, 7 and 11, 12. And it's talking about line segments and ratios and all sorts of things. Again, you might want to sketch this out. So sketching this out really helps, so you can see what this kind of looks like. They are telling you some information in the question. So if you see my video on vectors, you'll see I'm doing a lot of the similar stuff here to that. So 2/5 and 3/5 again, because you're sharing the line into fifths. So there's the point M and there's the P and the Q. Sketching it out helps. So the principle to this is very similar to the ones we were just doing. So find the gradient of this line, so PQ. So find the gradient of PQ. This you do by changing y over changing x again, same formula. So changing y will be 12 minus 7. So that's just obviously 5. And changing x, 11 minus minus 9, two minuses there. 11 minus minus 9, that's 20. So 5 over 20. So you're doing that real careful because you want to make sure you don't mix up your signs. So that's a quarter. That must mean the gradient of the tangent, so this line L they're talking about, is, again, flip this upside down, put a minus in front of it, minus 4. So the equation of tangent is what we need now. So we've got y equals minus 4x plus c, and I need to work out my c, but I need to know a point, first of all, y and x. So I haven't got my y and x, I need to know where my point is. The point M is the key point here we need to get. Now, to explain this as carefully as I can, it's important to look at what the diagram looks like. So from P to Q here, going along from P to Q along the x direction, we've got 20. It's 20 along, if you think about it, from minus 9 to 11. And from in the y direction, from P to Q, we've got, it's from 7 to 12, so it's from 5 up. So 20 along and 5 up. This is dividing it into 2/5, so we're doing 2/5 of that journey to get to M along, and 2/5 of that journey up to go from P to M. So 2/5 along and 2/5 up of that journey. So whereas we start with minus 9, 7, so this point here is minus 9, 7, we're going to go 2/5 of that journey along, so 2/5 of 20, so 2/5 of 20 along, so 2/5 of that journey along will be 8. and 2/5 of that journey up, so 2/5 of 5 in other words, or you can see that's just 2. So we're going to be adding 8 to the x coordinate, 8 to this bit, so -1, and then 2 to the y coordinate, 2 to 7 here, so that's just 9. So I know my point M now. My point M is -1, 9. That's 2/5 of the journey along. So now we can go back to my equation, y equals -4x plus c. We can put this point 9 in for y, and this point x -1. We can work out what your c is just by putting in your values. So I'll do that over here somewhere. So 9 equals, got to be careful of your signs. So notice how the -4 times the -1 makes +4. And then you're going to get 5 equals c eventually. So plus 5 equals c. So y equals -4x plus 5. And that tidies that up. One more question to do, which is again really similar and along the same lines. Just need to fold this up so I can show you it. Here's the question here. So again, similar question. Find an equation of straight line that is perpendicular to straight line x plus 2y equals 5 and that passes through the point 37. So again, it's a similar sort of question. So x plus 2y equals 5. Okay, it'd be nice to know what the gradient of this line is. So again, gradient of the line that we've been given, so we have to rearrange it. So x plus 2y equals 5 is the equation we've been given. Let's rearrange it into y equals mx plus c form. Okay, you take your time with it and you'll get it right. So it's minus x over 2 plus 5 over 2. So the gradient of this line is -1/2. So the gradient of the tangent will be obviously this fraction flipped upside down with a minus in front of it. So that's 2. So the equation of my tangent will be y equals 2x plus c. And again, I need to find a value to put into my equation for y and x. And we've got a point, passes through the point 37. So we're going to put 7 equals 2 lots of 3 plus c. That means that c is 1. So c is 1, sorry. And then that means that my equation of my straight line then will be y equals 2x plus 1. Okay, very straightforward. Okay, similar principles to the previous questions, but just a slightly quirkier question, a bit different, a bit unusual. Okay, I think that concludes the video this time for equations to tangents to circles. Do look through it again if you need to. Drop a like on the like button there, subscribe if you need to, and if you could drop a comment on the comment section below if you want me to do any more topics. If you want any more topics further, just hit the button on Twitch also. You can click on the chat box and tell me some other topics you would like me to do. I'd really appreciate it a lot. I hope you are enjoying your week and look forward to speaking with you soon. Thanks. Bye-bye.